Download this code from codegive.com, link in the description below. Depth buffers and ray tracing tutorial. Overview *. Depth buffers and ray tracing are fundamental concepts in computer graphics. This tutorial will explain both concepts, their purposes, and provide a code example to illustrate how they work. Depth buffers. What is a depth buffer? A depth buffer, also known as a Z-buffer, is a data structure used in 3D graphics to manage image depth coordinates. It keeps track of the depth of each pixel on the screen, allowing the rendering engine to determine which objects are in front of others. Purpose of a depth buffer *. Visibility determination *. It helps in determining which objects, or parts of objects, are visible to the camera. Overdraw management *. It reduces the amount of overdraw by only rendering what is visible. How it works *. 1. Each pixel on the screen has a corresponding depth value. 2. When a pixel is rendered, its depth value is compared to the existing value in the depth buffer. 3. If the new pixel is closer to the camera, has a smaller depth value, it replaces the value in the depth buffer and is rendered on the screen. 4. If it is further away, it is discarded. Ray tracing. What is ray tracing? Ray tracing is a rendering technique that simulates the way light interacts with objects to produce realistic images. It traces the path of rays of light as they travel through a scene. Purpose of ray tracing *. Realism * produces high-quality images with accurate lighting, shadows, and reflections. Global illumination * models complex interactions of light within a scene. How it works *. 1. Rays are cast from the camera into the scene. 2. The algorithm calculates intersections of these rays with objects in the scene. 3. For each intersection, the algorithm determines color based on lighting, material properties, and other factors. Code example. Here's a simplified example of a ray tracer that uses a depth buffer. We will use Python for this example. The code will demonstrate how to cast rays, check for intersections, and utilize a depth buffer. Requirements. Install NumPy for numerical operations. Code. Explanation of the code. 1. Sphere class * represents a sphere with methods to check for ray intersections. 2. Ray tracer function * initializes an image and a depth buffer. Iterates through each pixel, creating a ray from the camera and checking for intersections with spheres. Updates the image and depth buffer based on the closest intersection found. 3. Main block * sets up the scene with one red sphere and calls the ray tracing function. Displays the resulting image using matplotlib. Conclusion. This tutorial provided an overview of depth buffers and ray tracing, along with a simple implementation in Python. Depth buffers are essential for managing visibility in 3D scenes, while ray tracing offers a way to achieve realistic rendering. With this foundational knowledge, you can explore further optimizations and more complex scenes.